All right, everybody, we're going to continue our exploration of Aldol condensations and Claisen condensations. Here's our second activity of the day. A lot of stuff here. This is lithium diisopropylamide. That's a little scripted I with a PR twice. And it's a one-trick pony. It only knows how to take the least hindered alpha H. So let me just put all the alpha H's on this molecule. I think I just put the most hindered one right there. Least hindered one, two. I think this would be the least of the least over here. Those two. And we're making ring size 6. I hope it's clear. This is what I was talking about before that I wanted to do with the box I scribbled out in the previous video. This will work nice when you make ring size 6. And taking either these two or these two, the biggest ring you can get. And how do you do that? You count from the carbon that's going to become a minus to the carbonyl it gets attacked. 1, 2, 3, 4, ring size 4. I don't see products ring size 4. So you're not taking these H's. Same story over here. You take this H, that means you make a minus here. Ring size 1, 2, 3, 4. I don't see a ring size 4. You got it down to this H or one of these two H's. Which of those is less hindered? The two on the right. This has a methyl over here. This has 2 methyls. LDA only knows how to take that. So both reactions have LDA. Lithium's gone. Nitrogen has lone pair and a minus. Lithium's gone. Nitrogen has lone pair and a minus. It's doing the same thing in both mechanisms. Grab the least hindered H. Make an enolate. Grab the least hindered H. Make an enolate. On our first one, you're going to have unreacted ketone. 0.05 moles of unreacted ketone after I'm finished with this thing. The H there. How many CH2s? 1, 2, 3, 1, 2, 3, then the carbonyl. I didn't draw that very nice. Hope you didn't get that far. 1, 2, 3, then the carbonyl. You made that. 1, 2, 3. It's on the third one. 1, 2, 3. Yeah. Yeah. Uh-huh. And now that thing can react with its other alpha H right here. Instead of doing an aldol, it says, okay, I'm not hindered. I'm not like a big bulky LDA. I'm an enolate. I'm not bulky. So we just have an intramolecular acid base. Why? Because you have unreacted stuff. Unreacted. Sorry?
Did you ketone on the wrong side?
I got my ketone on the wrong side?
I don't, maybe not.
Oh, I put my minus on the wrong side. I agree. Yes. Wrong alpha position. Glad somebody spotted that. The minus is really down here, right? Grab that alpha H there. And you get this. More stable enolate. Because everything's under equilibrium control. Where am I going to put that minus? Sneak it up here. There we go. 1, 2, 3. The third one's the carbonyl. 1, 2, no, fourth one's the carbonyl. One, two, three, four. There. Very long. Okay, and then you're almost there. Almost there. Okay. No. Ding, ding. Ding, ding, ding. New bond. And new bond was to carbon. Right there. Looks suspiciously like the first product. We attacked a carbonyl that had an ethyl on it. Yeah. So all the way through, I lost a carbon. You guys are nice and polite. All the way, I lost a carbon. This is an ethyl here. There we go. So please fix it on yours. I just put this extra methyl on here now. And there it is again. And there it is again. Because this was a CH2 that went to a methyl. And there you go. And you're finished with the aldol stuff. Where's this H come from to give this product? Where's the H come from to give that product? Ah, why no less than HCl? This is step 2. Can't combine it with other steps. I know. You're probably having trouble squeezing that one in. Okay. Once, twice, 3 times. Is an anion. There you go. I did that right? I did it wrong again. You're putting a minus in the wrong spot. Do it in blue to be consistent. Ketone. CH2, CH2, CH2. Don't get fancy. The minus is right here. And that reaction's over. You know how I know it's over? Unlike this one, which was not over. Oh. What's the difference here? 0.95 versus 1.05. That's an excess. Excess means 100% reaction, no carbonyls left over. This one's limiting. Limiting LDA sets up equilibrium in the next step, which favors the better enolate. More stable enolate, better enolate. Enolate. Which is, it's called the thermodynamic. I won't be able to fit that word. Better enolate. And this one is the kinetic, which is kind of like saying the first enolate. First enolate that you can get is the only enolate that you can get because you used an excess of the strong base. And then you do this step here, the attacking step. No equilibrium. Step 1's over. The attacking step is now. And you make the thing that looks a lot like the second product. Here's your new bond. Here's your O minus. Here's your isopropyl. And that's HCl to get there. HCl to get there. Step 2. And these are all directed aldol reactions. Top 2, directed aldol. Bottom 2, you're attacking esters. Directed Claisen with a similar story. Limiting versus excess again. Same story. We got choices. More hindered H, less hindered H is on the left. LDA only knows one. Knows only how to do one thing. Take the least hindered H. Same story for both. They start the same. Least hindered H, C minus. I didn't even draw yet. Least hindered H, C minus. Goes to both of them. Oh, I gotta copy it. ETO2C goes to C minus. Goes to CH2 once, twice, 3 times with methyl. Comes to CO2 ET. I think that's it. 1, 2, 3, 4, 5. Yep. That's not fair. Which one will have equilibrium set up? Because you didn't react 100% of the molecules. First one, limiting. Once again, limiting. No, I don't use red. Limiting, pink. Let's equilibrium happen, which means you're going to take this H here. 1, 2, 3, 4, 5. It'll reach it too. Ring size 5 to grab it intramolecularly. Once again, that was equilibrium. Here's new equilibrium. ET, O, carbonyl, I drew it this time, CH2, C, methyl. Did I do that right? CH2, oh, 3 CH2s, bad. Here's the methyl. There's carbonyl. Here's your Claisen mechanism. Red first. Red first. Baby blue second. LG leaves. And you're out. I know you're totally out of room. Totally out of room. I don't like this arrow. Sorry. I like it better. You make what looks like the final product and you say you're done. No, don't do that. You think you're done because you actually have drawn the product that's right up above it. You're not done because you also made this Oh, you are done. Sorry, it's not that funny. OET minus. You are done. Because normally, OET minus would grab an alpha H from this position because that has a pKa of 10. If there's an H on this carbon, how do you know it has a pKa of 10? It's alpha to 2 carbonyls. That's our new one of our new ones. There is no H on that position. So this is another Claisen condensation. Then we normally finish it off with HCl. That's normal. I told you to just do it regardless. I did it regardless here too. But when you don't have an alpha H to take off, that's alpha to both carbonyls, you don't do it. Our next one, we're going to have to do it. Trust me. It'll be more traditional Claisen in our next one. And this is the product right here that you circled right here. Okay. Next one, straightforward. You can't have equilibrium here because you used excess of the real strong base. So Claisen starts right now. Electrons out, hit. Electrons come back. Leaving group leaves. I could have copy pasted. Well, couldn't really because we attacked a different carbonyl here. And it looks like you're done, but you're not. It looks like that first product. In fact, I'm going to make sure it looks like that first product because it does. I just didn't draw it right. Oh man, everything? That wasn't very nice. I'm really trying hard to make it look exactly like the first product. I think I was successful. But what about this H? What about the leaving group? If you think you're done, then you are sadly misinformed. You've generated a base that has a negative pKb. You have an acid with a pKa of 10. It's a new one. Keep reminding you. You can't stop. I know it looks like you're done. You say, I'm going to stop. You just lost 3 points. You lost a point for these arrows because these arrows cannot be stopped. You lost a point for this intermediate because this intermediate cannot be stopped. And then you lost a point for the mechanism that gets you from there to the first drawn product. Which you should circle. And that's HCl. You did need the HCl here. You can't combine HCl with other steps. It's a numbered step that's has to be done after you're finished the previous step. There you go, HCl. That's a more traditional way to finish off a Claisen right there. Big picture before we close this segment. There's a lot going on there. Directed aldols, directed Claisens. And I'll stop the share. See you for our last segment of the day.